Many times when a home run is hit at a baseball game, the ball ends up in the stands and never touches the ground again. But using the information from where the ball lands, you can calculate where the ball would have landed if it had never been obstructed by the seats. In this equation, h will equal the ball's height at impact, so how far above the ground the ball was before it hit the seats. S will equal the horizontal distance traveled, so how far it had gone when it hit the seats. A will equal the angle of impact of the ball on the seats, and K will equal the height where the bat met the ball. So to solve this, we will use a parabola, or y, and that will use the equation y equals ax squared plus bx plus c. And using this equation is much easier because it includes the outside factors such as air density and air resistance and stuff like that. And air density actually has a great effect on the distance the ball travels. A ball traveling at 400 feet at Yankee Stadium, which is right next to sea level, will travel 440 feet in Denver, which is a mile above sea level. So substituting these values into this equation, we'll find that h is equal to as squared plus bs plus k. Now, this a is not the same as the angle of impact, it's a different coefficient. And we can also use the equation tangent of a is equal to 2as plus b. So, using these two equations, h equals as squared plus bs plus k, and tangent of a is equal to 2as plus b, you can solve for a and for b. A will equal to the horizontal distance traveled times the tangent of the angle of impact minus the ball's height at impact plus the height where bat met the ball, and that will all be divided by the horizontal distance traveled squared. And B will equal to 2 times the height at impact minus the horizontal distance traveled times the tangent of angle of impact minus 2 times the height where the bat met the ball, and that will all be divided by the horizontal distance traveled. So for the first example, we'll use a ball landed 50 feet above the field, and it was 400 feet from home plate, and it landed at an angle of impact equal to 135 degrees. And we'll also assume that the ball was hit 3 feet above home plate. So, plugging in these numbers, we'll have h is equal to 50 feet, s is equal to 400 feet, k is equal to 3 feet, and a will be equal to 135 degrees. A is equal to 400 times tangent of 135 minus 50 plus 3, and that will all be divided by 400 squared. So A will come out to be negative 447 divided by 400 squared, and then negative 0.00279. We can also solve for B by doing 2 times 50 minus 400 times the tangent of 135 minus 2 times 3, and that will all be divided by 400. So B will equal to 494 divided by 400, and B will equal to 1.235. So, going back to this original equation of h is equal to as squared plus bs plus k, we can solve a and b, plug in a and b in the equation, so we'll get negative 0.00279 s times s squared plus 1.235 s plus 3. Also, we have to set h equal to 0 because we're trying to find how far the ball went when the ball hit the ground. So, after you plug this into the calculator and graph it, you'll find out you have to look for the x-intercept, and that will be the answer. And so in this equation, the x-intercept is 445, and so the distance this ball traveled was 445 feet. Now, it is rumored that Mickey Mantle hit the longest ever home run at 620 feet. So the values recorded for this was that the ball was hit, made contact with the seats at 115 feet, that it had traveled 370 feet, and this is where it gets tricky. It is said that the ball was at the top of its trajectory when it hit the stands, but since then it has been deemed highly unlikely that happened, and that the most conservative measurements for this are that the ball hit it at 150 degrees. And now, for simplicity's sake, we'll make k equal to 0 feet, which means he would have golfed the pitch, but this will only actually affect the answer by around a foot. So, using the equation h equals as squared plus bs plus k, and tangent a equals 2as plus b, we will solve for a, and we will solve for b. A will then be equal to 370 times tangent of 150 minus 115 divided by 370 squared, and b will be 2 times 115 minus 370 times tangent of 150 and minus 0. This would also have a plus 0, but since k is equal to 0, it doesn't really matter. And this also will be divided by 370. So, a is equal to 329 divided by 370 squared, and so a will equal negative 0.0024. B will be 443 divided by 370, and that comes out to 1.199. So plugging these values into the equation, h is equal to as squared plus bs plus k, and setting h to 0, we then solve this equation, put in the graphing calculator, and that will come out into 0 is equal to 500 feet.